My name is Vladimir, and I am a technical lead.
Sure,
No?
use this one.
Okay. Let's try again.
Yeah,
oh, much better. So my name is Vladimir, and I'm technical lead in Sardina, and here is my colleague
Konstantin Larin, cloud operations developer. And today we'll cover some. Oops, sorry. Today we'll cover some concerns and highlight approaches to managing and deploying OpenStack, and talk a bit about performance and stability. We'll cover some development issues and also how to upgrade the system.
Okay, let's talk a bit about OpenStack. So with OpenStack, you get a modern cloud platform, which allows you to have in the same platform virtual machines, bare metal, and containers. You have public cloud experience in your data center, so you control over what the data, where it is located. So sometimes it's very required today for GDPR or something else. It's also hardware agnostic. Maybe the only requirement is to support KVM, so you don't limit it by hardware. And a lot of open system vendors already have ready-made images with things like Cloud Init or Ignite, something like that. And while it's true, it's also not so big deal to do migration from the physical machine or from virtual machines, from other hypervisors. It's while we actually default to KVM, but thanks to LibVirt, it's also possible to integrate with other hypervisors. Next. So, OpenStack consists of many services, and lots of them talk to each other, and because of flexibility of that services and interconnection between them, it's a very bad idea to try to do that manually. You have to have any sort of automatization, or you also need to be sure that your configuration options, for example, Nova talks to Neutron, and if your Neutron configuration is wrong, you will not get working system. So also one of the things that by architecture, OpenStack built to easily support high availability. You easily can scale out, add more compute. You easily can add more storage or other storage. You can have several at once. To be able to support your system, you should have automation that covers all the stages of lifecycle, from the deployment to operation stage and to upgrade. Also, it's very important to have a monitoring system for your entire infrastructure, and also to gather logs from your system. Also, it's usually maybe sounds a bad idea to have debug logs enabled by default, but actually in real life you can have a lot of additional knowledge what the causes of some troubles if you have that's on by default. And it's also maybe sounds bad for production, but better to have also tracing enabled. So time to time you have option to run some queries with tracing and collect your knowledge about bottlenecks or some other problems.
So yes, we've come to a topic of performance and stability. So all components of OpenStack are Python-based. This makes development and debugging easier, but also comes with a cost of higher resource usage. And you often should take care of resource limits. We implement this in our practice with built-in settings of services and also systemd overrides, particularly C groups. Some settings may be calculated dynamically. For example, you would most likely want to make reserved memory on hypervisors. For example, 5 gigabytes plus 3% of total memory available, which works well. Proper resource limits of hypervisors let supporting components run smoothly under high load. This especially important for networking stack and third-party storage drivers, for example. Regarding network, OpenVSwitch, for example, it's a very resource-intensive service on hypervisors, especially on busy hypervisors. And you may want to pin it on specific CPU cores and restrict VMs from using those cores. To accelerate storage, for example, if you use spinners in your shared storage, you most likely would benefit from placing VM root disks on hypervisor SSDs. This also works well, and this works in several sites we support. This is also very cost-effective. Regarding control plane, it's built around message queue service. RabbitMQ is the standard, and it's also the most CPU-intensive task on controllers. And you may want to also tune it to fit your deployment. There is one special parameter that you most likely want to tune is scheduler threads count, which allows to balance between CPU usage and ability to quickly dispatch messages. Again, regarding RabbitMQ, message delivery reliability is very important here, and RabbitMQ development recently shifted to quorum queues and streams, and even deprecate classic mirror queues. But OpenStack only recently became to support quorum queues, and the streams feature hasn't even touched the code yet, which brings us to our next topic.
Yeah, and that brings us to a problem with development challenges. OpenStack have lots of dependencies. It itself have like 200 packages and much more dependencies. Some of that dependencies also quite often deprecate Python versions, like cryptography package, which often deprecate your like Python 3.6 already gone, 3.8. I think it came to the same stage. Some of other problems that some of the features takes longer time to implement, like unified limits in Keystone. It's while maybe sometimes it's listed as ready-made, it's not, at least not for Antelope or Barbican. Oh, sorry, Bobcat. And some of services doesn't take much attention from developers. And for example, Truth, it's a database as a service, only can run simple configurations of MySQL or MariaDB with a single server, nothing more. There are lots of challenges if you have third-party drivers sometimes for storage or for something else, because they often doesn't reach the same pace of OpenStack releases. For example, one of that packages still want to have Keystone API version 2, which is ditched in Queen's release, which is 2018. So much time, it's still there. Also, if that service doesn't take attention from the developers, you likely have to do the patch your own, and to be able to do that, you have to have some testing environment where you can run your tests, like Tempest for interop or something else. And let's go next. Yes. And since that speed of OpenStack releases, new version, you actually want to go for upgrade stage.
Yes, OpenStack releases come out each 6 months. They gather all new features and all bug fixes during that period of development. But many operators prefer to avoid this topic of upgrading. Latest OpenStack user survey showed that most users run Yoga release. It was released in March last year. But second in popularity is Train. It was released 4 years ago. So why would you risk breaking the cloud that you built and spend so much time on polishing, and it works fine, and even if you did not want to run anything besides simple VMs, so why would you upgrade? Actually, you would be still affected by security issues, and especially operating system coming out of support. Like an example of this is CentOS coming out of support next year. So all releases up to and including Yoga would be in risk that run on CentOS. So the ultimate solution to upgrading is to plan on deployment stage. You need a knowledge base that would gather all your changes and customizations. These changes must account for new releases and implement changed functionality, and also these changes must be all automated. Along with simple approach, where you could simply run a playbook to do everything for you. That's of course during scheduled maintenance. You should have granular controls over what you upgrade, what service you upgrade, at what stage, and on which host. To save time during actual upgrade phase, where database upgrade tasks and service restarts happen, you would benefit by offloading non-invasive tasks from maintenance window. That includes backups of control plane. This includes configuration and databases. You would most probably would like to stage packages and complete all online data migrations tasks. You should also plan for live migration of VMs, and for that shared storage is not required, but it would greatly save time.
So to sum up, with OpenStack you get cloud experience, which allows you to run virtual machines. You also can use bare metal installations and containers in the same platform. They can be in the same project, in the same tenant. It's also can have quite complex configuration of networking, which may need your needs. from the simple flat networks to a much comprehensive one with the SDNs and more add-ons. We believe that only with automation it's possible to run at high scale, and that's to achieve latencies you should take care on planning, and that's regular updates is a quite maybe frightening task for some of, but it's something needed to be done, especially when something like CentOS 8 goes off and something like that. So that's all. Please, any questions?
Thank you very much. Two of the great talents in Sardina that we don't often let out, so thank you very much, guys.